So let's say I decide to switch that bromine to an alcohol. Let's say I run a nice reaction. I have sodium hydroxide, bumps out the bromine, and I end up with 2,5-hexane diol. And it creates two chiral centers for me, and I draw all the Fisher projections. So I have, in this case, I start with 2R5S, but I can get 2S5R, 2R5R, and 2S5S. Are all of these truly enantiomers and diastereomers? Well, here's the weird thing. So if I look at the 2S and the 5S and the 2R and the 5R, these are truly enantiomers. And the reason that they're enantiomers is that if I were to take this mirror image, I can't possibly rotate along a chiral center to recover the starting molecule. But if I look at the top one, this is not actually unique. So if I look down the center, here and here, and I take the mirror image, what I see is a mirror image top and bottom. So there's two hydrogens here, a hydroxide here, and a CH3 group here. If I take the mirror image like I have, I'm going to end up with the hydroxides on the right side. But let's say I take this mirror image and I turn it 180 degrees. If I rotate it 180 degrees, that hydroxide will go there, that hydroxide will go there, and I end up recovering the parent compound. So by definition, this is not an enantiomer. But if I do the same thing with this one, if I take the mirror image and then I try to rotate it 180 degrees, the hydroxide is going to come here, and the hydroxide is going to come here. So these are enantiomers. They can't be superimposed. So how do we draw this? How do we describe this top case where if we do what we're supposed to do with the Fisher projection and we change both the R and the S, but we still end up with the exact same compound related by symmetry? Well, instead of using this RS notation, we're going to call this meso 2,5-hexane diol. And what meso compounds are compounds that contain chiral centers, but the molecule itself is not actually chiral. You can actually take the mirror image and superimpose it on its old self. Now, this is not going to be true for the 2S5S and the 2R5R. In the case of these, we do need to specify that it's 2R, 5R, or 2S and 5S, but because these two are equivalent, we don't specify the chirality at either center. We just say that it's meso. So, big, easy way to catch out if you've got a meso compound. Draw your Fisher projection and look to see if you see an up-down symmetry. If you can draw a mirror plane between carbons or along a bond, probably what you have there is a meso compound. So those two chiral centers, for whatever reason, the symmetry just works out and they don't end up creating a chiral compound in the end.